Hello everybody. Last time we did some experiment with aluminum. We put some aluminum hydroxide in water and it didn't dissolve, and then we added some acetic acid solution, and we let it sit and it didn't react. And the reason for that turns out to be because of the solubility product of aluminum hydroxide. It's 1 × 10⁻33, which is a tremendously small number, so very insoluble. Then we added the acetic acid, it didn't react. But now we're going to do the same experiment, except we're going to use hydrochloric acid. Now hydrochloric acid, unlike acetic acid, is a strong acid. It's completely ionized. And so if you have 1 molar acetic acid, the hydrogen ion concentration is 1 molar. Okay? Keep that in mind. So it's much higher hydrogen ion concentration, much lower hydroxide ion concentration too. And you're going to have to, let's get some aluminum hydroxide. Remember that was the white powder? We're going to put the same amount as we did last time in this test tube. It has 10 milliliters of water in it. Let me get it off the sides here. And it doesn't dissolve just like it did last time. Now here I have 2 milliliters of, that's 6 molar hydrochloric acid. So when it gets diluted, it'll be about 1 molar in that solution. And let's see if it's dissolving. It's and reacting. It should dissolve and react. That's what we predicted anyway. Okay, now I'm going to add 6 milliliters of 12 molar HCl. Let's see if there's any evidence of reaction. Is there any? Yeah, there is. There is evidence of reaction. Can you see it? It is bubbling. And that should be hydrogen gas. And we'll let it go for a while. Because the reaction is exothermic, and it starts getting warmer and it starts going faster too. But it is reacting. You can see the bubbles, right? Okay, look at that. That's the aluminum with the hydrochloric acid. It's going a lot faster because it got hot, and reactions go a lot faster when it gets warm. So what I'm going to do is put this bottle over the top to collect the hydrogen, and then we'll see. Okay, now whenever the aluminum reacts with water, it makes aluminum chloride and hydrogen gas, and so we're going to test the gas again, see if it's flammable. Yes, it is. You have verified it. It actually supports the notion that hydrogen will be. Looks like the aluminum hydroxide is reacting with the HCl. There's hardly any left. There's still some in there, but we'll check in another 5 minutes or so. This is a pH meter, and we're going to measure the pH of the solution of aluminum nitrate in water. This is aluminum nitrate here. You see it's a white crystalline material. That's aluminum nitrate. I'm going to put it into this small beaker here. And we add 20 milliliters of water, and we're going to dissolve it. And we're going to measure the pH of the solution. Okay? It's very soluble in water, so it should dissolve. See, it is dissolving. Can you see it? It is definitely dissolving. Let it dissolve a little bit. And I have the electrode from the pH meter sitting in water now. And I'm going to move it over here in a second. And we'll see what the pH is. And if pH is less than 7, it's acidic. And the lower it is, the more acidic it is. Okay? That's probably enough in there. So I'll take the electrodes over here. Can you see the meter? So I'm going to stick this in here. See what happened to the pH? Can you see it? What is it? 2.75? Can you see it? 2.75? Yep, that's acidic. Okay, this is a model of the aluminum ions at the center, and it attaches itself to 6 water molecules, and the formula is AlH2O6 with parentheses around it, and the whole charge is +3. And what happens is the strong bond of the oxygen makes the hydrogen atoms much more acidic than in regular water. So these are actually acidic. 250 milliliter beaker, and I have here 5 grams of sodium hydrogen carbonate or sodium bicarbonate or baking soda. And what happens is baking soda reacts with acids to make CO2 and water. Okay? And so this is acidic. This is the aluminum nitrate solution. I'm going to add half of it over there, and we'll see if there's any evidence of it reacting. And if it does react with the baking soda or sodium hydrogen carbonate or sodium bicarbonate, it should make CO2. So we should see effervescence. Do you see effervescence? You see it? Those bubbles are carbon dioxide. Now, there's a good test for carbon dioxide. First of all, carbon dioxide is heavy, so it should fill that up from the bottom up and fill up. Let me put the rest of it in here. And what I'm going to do is take a wooden split and light it and stick it into that carbon dioxide. And if it is carbon dioxide, it should tell us by the following way. You see the fire burning? See it go out? Because it doesn't support combustion. And the fact that it put it out and the fact that we're staying in there means it's heavier than air, and it's a good chance that that's carbon dioxide. That's a good test for the carbon dioxide. This is the aluminum hydroxide with the hydrochloric acid. The aluminum hydroxide is almost all gone now. It just takes a while. It's kind of a slow reaction. Liters of water, and I'm going to add 2.5 grams of aluminum nitrate, so it should dissolve like it did before. And once that dissolves, then I'm going to add I can open this bottle. 6 milliliters, or no, I'm going to add 3 milliliters of 6 molar sodium hydroxide solution. A bit more. It's too much. I'm going to add that to this. And since aluminum hydroxide is insoluble, I think we might get a precipitate. Let's see. Yep, we get a precipitate. Everybody see that all right? Now what I'm going to do is I'm going to add more sodium hydroxide. And that precipitates aluminum hydroxide. I'm going to add more sodium hydroxide, 12 more milliliters. Actually, I'll make it 6. I think that might be enough. And let's see what happens. If that's not enough, we'll add a little bit more. Can you see anything happening? Did it disappear? It disappeared, didn't it? Everybody see that all right? Okay. Now what was happening is I was adding a base and the aluminum hydroxide reacted with it. The aluminum hydroxide was acting like an acid in this reaction to make a sodium aluminate, which is soluble in water. Okay, so aluminum hydroxide can either act as an acid or a base, depending on what you're treating it with. If you treat it with an acid, it acts like a base. If you treat it with a base, it acts like an acid. We call hydroxides like that amphoteric hydroxides. So aluminum hydroxide is amphoteric. The oxides are also acids and bases, and if it has amphoteric hydroxides, they're also the oxides are also amphoteric. They'll act as an acid or a base. Now we saw that aluminum reacts with hydrochloric acid because the hydrochloric acid removes the aluminum oxide or hydroxide coatings. And I think sodium hydroxide should do the same thing. So we're going to try that in a little bit. Okay, now we now know that sodium hydroxide solution will react with aluminum hydroxide. So I think sodium hydroxide to remove the oxide and hydroxide coating from the aluminum, and it should react. You see any evidence of reacting? Let me shake it up just a little bit. Yeah, I see some bubbles. You see some bubbles? Yep, it is reacting. It's a little slower though. So what I'm going to do, after it gets going a little bit, we're going to go into another laboratory where there's a Bunsen burner and we'll heat it up. The reactions always go faster at higher temperatures. If it does speed up, then we'll come in here and test to see if that's hydrogen gas. Burner. And there's a draft in this room, but that's all right. Now I'll start heating it up, and it should start going faster when I get it heated up. Let's see if there's any evidence of it going faster. It is going faster, isn't it? You see it? You see it is going faster? Yeah, it is. Now, if that reaction is what we say it is, that should be hydrogen gas coming out of there. And the way to test for hydrogen gas is to test for its flammability, isn't it? Look at that. It is going faster, isn't it? Yep. Get a little bit hot, and then we'll go in there and collect some of the hydrogen and test it. Look, it is going faster. Definitely going faster now. Faster now. And what I'll do is I'll put the bottle over there again and see if we can collect the gas. And if that is hydrogen gas, we'll do it for about a minute or so. If that's hydrogen gas, then you know what it should do. Okay, do you think that's long enough to test? Let's see. Let's test it. Let's test that. Let's see. You think it is hydrogen gas? I think it is. Let's see. Yep, it is. You get that one too? 2 tests. Another test. One more.